Hi everyone! In this fourth lecture, we will explore new features of functions. First one is modules. There are three different ways to use modules: built-in modules, your own module, or packages. You can use in your code any function defined in the module without even knowing what there are under the hood. We will learn how implicitly document the parameters of a function, star arguments, double star keyword arguments. To increase modularity of function, we will create decorator and use it with any appropriate function to modify or extend the behavior of the function. We will discover another type of loops called recursion, in which the function calls itself but with a base condition. Finally, we will create generator, which is a function that yields something and store its final state, and when called again in your code, begin its computation from its final state. You can import the whole module with import statement. You can rename the module with import module as lambda statement, or you can partially import a module, a feature of a module, or a function of a module. Imagine I created a Python file called util.py in the current directory, and in this file I have a function called word counter. In another Python file, always in the current directory, I can import util as a module. I can partially import util module from util import word counter and directly use the word counter function of the util. Or I can import the whole module, then I will use util.wordCounter. The Python standard library URL address is docs.python.org/tree/library/. And some of the famous modules are string, datetime, math, random, itertools, and collections. If you want to use packages such as NumPy, a package for scientific computing with arrays, you have to install the package. First, go to the Python packages and search for NumPy, and then install. Or go to the terminal and type pip install NumPy. Whichever method you use, you will see NumPy package in Python packages. As an example, import NumPy as np, compute np random integer between 9 and 17 and 3 by 4 array. Then print a, and it prints the array a, 3 row by 4 column with random integers between 9 and 17. pypy.org compile all public Python packages. Star args, double star keyword args. Star args is a sequence and double star keyword args is a dictionary. If the function parameter is star args, you can call the function with as many arguments as you want. For example, I have a function called find total with a parameter star args. Initial value of total is 0, and for arg in args, increment total by arg. At the end, return total. I call this function with some arbitrary arguments such as 32, 54, 62, 12, 34, and it returns 113. I could have called the same function with more arguments or less arguments, but it will always return the total as long as the arguments are numbers. Another example, a function called area with star args and double star keyword args as parameter. The function computes the area of a basic geometric shape such as triangle, rectangle, circle, or a square. The parameters base and height if a triangle, a and b if rectangle, radius if a circle, a if square. Keyword arguments, there is only one, which is form, and it can be triangle, rectangle, circle, or square. At the end, it returns the area of the given geometric shape. Print an alert if the form is different. If keyword arguments form is equal to triangle, return args 0 multiplied by args 1 divided by 2. Else if keyword arguments of form is equal to rectangle, return args 0 multiplied by args 1. Else if keyword arguments of form is equal to circle, return pi multiplied by args 0 square. Else if keyword arguments of form is equal to square, return args 0 square. Else print f string keyword arguments form is not recognized. I will call area function with three different arguments. First one, print area with parameters 3 and 5 and keyword argument form triangle, and it returns 7.5. In the second example, print area with parameter 5 and keyword argument form circle. It returns 78.54. And lastly, print area with parameters 2 and 3 and keyword argument form cone. It returns as expected. Cone is not recognized. Python decorators allow you to modify or extend the behavior of functions without modifying their content. Python decorator wrap a function with another function, which takes the original function as an argument and returns its modified version. The syntax is as follows. You create your decorator, which takes one argument, the function, and in the decorator function, you define another function, a wrapper function, in which you do something, you execute the function and assign the result to a variable called result, res. You do something else and return the value of the execution of the function, but it is not compulsory at the end of the wrapper function, and the decorator function return the wrapper. When you type at decorator before creating your function, and in your function you do something and return something. When you call the function, if a decorator is not used here, it would do the same thing as calling the function, decorator function, decorator with the parameter function. For example, I create a function called 2times, which takes one argument function, and in which I define a wrapper function which executes 2 times the function, and at the end 2 times return the wrapper. I create another function called greeting, and it prints good morning universe. When I call 2 times function with greeting, it will print good morning universe, good morning universe. It will print twice. On the other hand, I do the same thing, but the first function I create as a decorator, and I add in the syntax add decorator at 2 times. Then I create my function, greeting function, and when I call greeting, it will print twice good morning universe. Recursion. In recursion, one should identify a conditional base case in which the function return or do something. If the condition is not satisfied, the function invokes itself in the body of the function with the objective to converge to the base case. Ensure that the recursion is not endless. For example, I create a function called factorial of n. It takes one argument n, it's an integer. I know that the factorial of 0 is 1. So my base case is if n is equal to 0, return 1. Otherwise, return factorial of n minus 1 multiplied by n. For example, to compute factorial of 3, it will compute factorial of 2 times 3. To compute factorial of 2, it will compute factorial of 1 times 2. To compute factorial of 1, it will compute factorial of 0 times 1, and factorial of 0, when you call factorial with 0, as n is equal to 0, it will return 1. Once it reaches the base case, it will recompute all the values of factorial starting from the last point. That is, 1 times 1 is 1, 1 times 2 is 2, which is the factorial of 2, and 2 times 3 is 6, which is the factorial of 3, and it will return 6. Generator function is a function that behaves like an iterator. You can use it in a for loop. A generator should have at least one yield statement. When yield is executed, generator returns the yield value and pause. That is, does not exit from the function. When you call again the generator, it continues from the same point. For example, create a Fibonacci number generator. Create 2 variables, a and b, assign 0 to a and 1 to b, and within a while loop, first yield the value of a, then create a temporary variable, temp, and assign the value of b to it. Assign the value of a plus b to b, and then assign the value of the temporary to A. To call a generator, use the next built-in function or iterate within a for loop, but be careful because generators are generally endless. So for this example, I will stop the loop if I exceeds 212. Wrap up. In this lecture, we dived into the more sophisticated features of functions in Python. We don't have to create every function. We can refer to the modules and use the methods of the modules. It provides us enormous time saving and let us explore new universe. Implicit parameters of functions, star args and double star keyword args, enhance the degree of freedom of functions. Decorators are modular so that we can combine with many different functions to change the behavior of the function without rewriting the code. Recursion is a technique to invoke the function itself within the body of the function with a base case identified, which can simplify drastically our codes. Generators gives us more power and flexibility on iterations. Join me on the next video for tutorials.